Okay, so my name is Rose Mbugua. I'm from Sisulu University, Eastern Cape, South Africa. And the topic of my presentation is polymer-based nanomaterial, gum acacia as admixture for concrete. And my co-author is Dr. Wolfram Schmidt from the Department of Safety of Structures in the Material Research in Germany. This is the overview of my presentation. There is introduction, uses of gum, experimental work, results and discussion, and then conclusion. So Africa, just a minute, let me push this. Africa is one of the continents where there are many projects being undertaken now because of the big population and also the requirements for infrastructure and housing. Also, small projects are on the rise. Naturally, people are choosing concrete because it is one material that is abundant and the raw materials are easily available. So Africa has a very good chance to be innovative in the way we design our concrete. So one component of concrete that we really need to pay attention to is the chemical admixture. Unfortunately, in Africa, all the chemical admixtures are imported from industrialized country. And therefore, this study is meant to develop an admixture which is easily available in Africa. In this case, we use a gum from a tree called acacia. This gum grows in Africa in two species. There's one called Sial or Senegal, which grows in the North African countries, and Acacia carauhense, which grows from the South African countries. So you can see these are the gum, we call them the tears. This is when the gum dries up. Here, the below picture is where the gum is oozing out from the bark of the tree. And this is the tree itself. So naturally, gum has been used in the industry. It has been used in beauty products, in pharmaceutical industry, also in the food industry, in Coke and chewing gums. It is also food for bush babies, and the other parts of the tree are used for other uses, like the wood is used for roasting meat and so forth and so on. In concrete, this gum has been identified as type D admixture. Type D admixture means that it has a set retarding and water reducing state. That means it can do water retarding, or it can also be a water reducing admixture. Just a minute, please. Let me. Just a minute. Let me just share something else here. Okay, let me continue with this one. I hope you can still see my screen.
Yes, I can see it.
Okay, let me put this one down. So in concrete, this admixture has been used as type D admixture. That means set retarding, water reducing admixture. And the importance of these admixtures is that you can be able to increase the slump even without increasing the water. it is they are very important, especially when you are doing concreting in hot weather climates, because it increases the setting time. And also, we can be able to decrease the cost of concrete. As you know, concrete, especially the cement, is the most expensive component of concrete. Now, the purpose of this study was to see how it affects, or the time you add the admixture to the cement, how will it affect the rheology of the pastes. So this study was conducted using not an ordinary method. It was conducted using indentation method, which is usually used in the food engineering. It is used to identify flow behavior of complex fluids. The depth of indentation was used to show or to identify the flowability of the cement pastes at an early age. A dosage of 0.8% of the weight of cement was selected for all the mixes. This is because we had identified 0.8% dosage as an optimum dosage for the cement paste. In addition, we did zeta potential, we determined the zeta potential of the Acacia Gum using in deionized water and also saturated calcium hydroxide. The methodology. So in our method, we used the zeta potential. We measured 0.04 grams of the Acacia Gum and dissolved it in water and also in concentrated calcium hydroxide. Malvin Zeta Caesar Nano ZS was used to measure zeta potential. For the texture analysis, which is the one I talked about, it is used in food industry. A texture analyzer CT3 was used to determine the force that was needed to ident a sample of cement paste from a predetermined distance upon trigger. So Acacia Gum was mixed with 0.08% dosage, and we used water ratios of 0.3, 0.4, and 0.5. The cylindrical probe that was used was tube probe, which was 25.4 millimeter, and the speed for lowering it was 1 millimeter per second as it was being inserted and also when it was being retrieved. The force required to compress the material was then measured using the ProCT software. Okay, then we added the Acacia Gum at 3 different times. The first sample was prepared with the cement, or the cement was added to water, and after mixing for 2 minutes, then the powdered Acacia Gum was added and mixed. Then the mixture was further mixed for another 2 minutes. The other sample, we added 20% of the batch water with the Acacia Gum. It was mixed for 2 minutes. Next, cement was added. It was mixed, and then later the remaining 80% of batch water was added, and the mixing continued for 2 minutes. Then the other sample was used or was prepared with Acacia Gum and OPC, that is the cement. These are the dry ingredients. They were mixed together in the dry state, and then water was added, and then the whole mixture was mixed for 4 minutes. Then the control was just the OPC or the cement with water. So these are the results that we got from the zeta potential. They showed that the zeta potential became more negative with age, indicating deprotonation. That means from 1 hour to 3 hours to 5 hours, the zeta potential became more negative. This is unlike other polycarboxylate ethers, which actually do not become more negative, they become more positive. So it can be observed that with time, the zeta potential in all cases become more negative, and that indicated that there's deprotonation of carboxylate. Then for the texture analysis, these were the results. At 1 hour, and 3 hours. So these are the forces that were identified or that were recorded when the force or at after 1 hour. Here we could see that the force required increased with age, but decreased with the water cement ratio. So these are the water cement ratio, this is the force. And the force needed at 3 hours, which is this 3 hours, of age, it was double the force that was needed at the same hour, especially for 0.4 water cement ratio. At 3 hours, after 3 hours, the control actually stiffened, and we needed a lot of force to penetrate it. But from here you can see that all the samples with Acacia Gum, there was minimal force needed. So after the 4th and the 5th hour, these were the results. And it was visible that after 4th and 5th hour, the samples prepared with especially 0.3 water cement ratio required more force. Of course, this can be attributed to the fact that the 0.3 water cement ratio did not have enough water to dissolve the gum. So most of the water or the little water that was available went to the hydration of the cement. But as we increase the water cement ratio, we can see now the gum being active and becoming a plasticizer, and hence making the pastes more flowable. So this is the 4th and the 5th hour results. So in conclusion, we can say that the zeta potential of the Acacia Gum dissolved in water and calcium dihydroxide was negative. Okay, that indicating that the polymers adsorbed on the particle surfaces. Then gain of strength of samples was influenced by the water cement ratio significantly, as opposed to the time of addition of the Acacia Gum. Then we also concluded that the delay in the addition time of Acacia Gum had slight improvement on rheology at an early stage. At an early age, with high water cement ratio, the formation of gel was almost negligible for samples with AG, while the control gained strength as expected. Although this method has not been used in cement industry or in construction industry, it is recommended that this type of measurement using the texture analysis be further exploited, because it can reveal to us exact time the paste starts to stiffen. And if it is well developed, it can actually inform us about the microstructure formation of the paste in a shorter time compared to the other penetration tests such as VCAT. And our recommendation was that further studies should be carried out to see if there is long-term effect on the addition of Acacia Gum. The authors of this paper would like to sincerely thank BAM, or the Federal Institute of Materials and Research, where all resources were used for this study. Thank you very much.